As artificial intelligence continues to grow in adoption, what does that mean for cybersecurity? Along the same lines, what is post-quantum cryptography and how does that influence cybersecurity? I'm James McGuire, and on today's Tech Voices, we're talking about key trends in cybersecurity. I'm joined by a major industry expert. With me is Vidya Shankaran, Field CTO at Commvault. Vidya, really good to have you with us today.
Thank you so much, James. Appreciate it.
So we've got some great topics to talk about. Before that, I'd love to hear about your career, how you got to be CTO, what you've seen along the way. What's interesting about that?
Sure, happy to talk about my experience along the 20 odd years that I've been in IT.
Mm,
I'm going to date myself here when I say that I started out my IT career as an application developer on AS400.
that's impressive. It is, yeah.
Yeah, but like I said, back then, as in terms of an application development, security was less of a conscious decision. It wasn't really front and center. But over time, I would say that, especially in the last 5 years, given the cyber context of things and throw in the AI moving parts to the equation, I
Hmm.
think we have a very complex set of problems that IT enterprises across the globe are trying to solve for. And happy to double click into any facet that you'd like to hear more from.
Well, that's really that last point you talk about. There's some key problems. What are those problems you're referencing, just in particular?
So interestingly, in the past 5 years, especially in the cyber realm of things, I think we are well past the patterns of the quintessential Nigerian prince.
Hmm. Right. I
Gen
don't get emails
AI,
from him anymore, actually. Yeah.
exactly. We don't, and maybe even if we did, it's phrased so accurately. It sounds almost professional, and all
Hmm.
thanks to Gen AI. And not just that, I think the overall evolution of threat vectors have definitely seen a massive upskilling, so to speak, again,
Hmm.
with the advantage of Gen AI that democratized that the availability of technology to the masses.
Right.
So over time, this has been a massive shift in the way we traditionally look at things. We are now looking at cyber resilience not just an IT problem. There is the people aspect to it, there is
Right.
the process aspect to it, and acknowledging the fact that humans are the weakest link within an organization or the
Right.
first line of defense. I think that has definitely put things in perspective for organizations today.
Interesting. Well, one of the things I think is really interesting about that is that there's companies that are trying to get over an attack. I mean, they've done everything they can to block it. Maybe they've been hacked, maybe it's ransomware, but now they're trying to get over it. So, what do you see in terms of some current challenges customers face in recovering from a cyber incident these days?
So, in terms of recovery itself, right? The recovery mindset is something that needs to start well ahead of the curve. And what I
Hmm.
mean by that is many organizations assume that throwing technology or technological investments at a cyber resilience problem will solve for it, but unfortunately not.
Hmm.
So when you take a step back, or maybe several steps back, organizations are expected to have the minimum viable requirement or minimum viable business ready to run, without which that entire business is entirely shot at the knees.
Aha.
Now, how many customers or environments actually have that inventorized or charted out? I would say very handful.
And so, all right. So, what is the minimum viable strategy?
Oh, that's a great question. Minimum viable strategy is um, actually distilling down the business requirements to the core capabilities, without which an organization is essentially done for good. For
Hmm.
example, if I could kind of elaborate a bit, in healthcare,
Hmm.
patient onboarding is minimum critical capability. Then access to EHR data, allergies, medication, treatment plans, those are minimum viable. That means without that piece of information, and let's assume that the healthcare company is not able to bounce back or restore that data,
Hmm.
they are essentially out of business because they are not able to cater to the business consumers of those services.
Hmm. So let's talk about large language models. I mean, why is large language model poisoning an area to watch as AI continues to grow in adoption?
Sure, that in fact that's a fantastic question, James. And I think especially now when organizations are rapidly adopting and adapting to the AI ecosystem itself, the LLMs under the hood are expected to be memory efficient because they are extremely memory intensive operations. And in order to be memory efficient, what happens is there is a process called quantization of LLMs.
Okay.
So, in other words, LLMs are actually tapping into a pre-ranked URL, or it could be looking at time edits before a particular snapshot of that repository of data has been taken, such as a Wikipedia, right? Now, what happens is there is a huge possibility for humans to go in and tweak with malicious intent the URL's ranking. I could put up spurious links up that comes up on top, making sure that it in turn completely poisons the well, poisons the LLM, poisons the ranking or the first response that you would get out of your Gen AI tool.
Can I ask a question about that? So how are they getting the URLs in that position? Are they sort of like gaming Google to get the search engine ranking? Or how does that go?
You got it. That's
Okay.
exactly what's happening.
All right.
And sometimes what happens is there's another emerging trend. For example, a particular website has not been renewed. Malicious actors will definitely go in, buy that URL, pump it up with malicious or incorrect data sets,
Hmm.
which in turn vitiates the entire LLM data set, right? And that completely skews the way the world starts seeing the output. It could be a banking site. Let's say I just want to look at let's a tax return filing calculation.
Hmm.
And a malicious actor could have intentionally changed the formula. Now, inadvertently, I'm going to trust the banking website's ability to churn out the right numbers, but not realizing that it's actually been compromised. So
Uh-huh.
now the downstream process is completely ruined in terms of my output.
Well, then is there a way to guard against that, or what's the solution there?
Wish the answer were that easy because most experts today are struggling to have a better understanding around how LLMs actually work, which is alarming at the same time.
Right.
The only to answer your pointed question is to have a pair of human eyes validate each and every data set. So human in the loop is, I cannot overemphasize enough on that particular point because human in the loop is definitely a core requirement. Expecting AI to be autonomous is a massive risk because we end up creating an echo chamber around us that would completely warp our understanding of the world as well.
It's actually good to hear that. It's good to know that we humans are still needed. So it's almost reassuring. Like there's a place for us in the AI world. That's a good thing, I think.
That's right.
Uh, I find this idea really fascinating. The idea of post-quantum cryptography. Now, I know about quantum computing, and then when that really comes around and it really is fully mainstream, that's going to change a lot of things. But in the meantime, what is post-quantum cryptography? You PQC, and what does it mean for cybersecurity?
Yeah, PQC is definitely a key trend or conversation topic within large enterprises, especially the highly regulated industries today. Because, long story short, what happens, James, is when you look at the current classical algorithms that we have, the current symmetric encryption algorithms, which could be AES 256, that is the most preferred algorithm for data at rest.
Uh-huh. Okay.
Is that secure? 100% it's secure. But what is not secure is the asymmetric encryption, which is typically what you would use for data in transmission. So only because there is a possibility that the keys are compromised by a man in the middle, you would want to make sure that you make it that much harder for the malicious actor to make sense of that data, sense of that encryption key itself. So you have two methodologies. One is the key encryption key method. So the KEM, MLKEM is one of the most advocated for NIST by NIST themselves,
Hmm.
which is key encapsulation lattice space algorithm. And the other one is the digital signature one, which is the dilithium or MLDSA. So over time, we are expecting NIST to continuously revise and add more and more algorithms that make most sense in this.
Hmm.
But in terms of the risk, from a cybersecurity perspective, data that is encrypted, we assume is of least value to malicious actors, which is actually incorrect.
Right.
Especially the malicious actors who are in for the long con, maybe nation state actors who are in an environment, critical infrastructure environment for maybe 5, 10 years, they ensure that they are not seen or identified, and they fly under the radar as long as they can because they are extracting even encrypted data or exfiltrating encrypted data out of the environment. The reason being, that data may not have immediate business value today, but long term, when quantum computing becomes a lot more stable,
Right.
they tend to use that encrypted data to be decrypted using the commercial models of quantum computers at that time and leverage that intel against a nation state. So is PQC meant for commercial use, or are you protecting yourselves from commercial attackers? Not necessarily. This is for long-term scheme of things, making sure that especially you're safeguarding your IP, your in-house intel as much as possible from long-term attacks.
Hmm.
It's definitely not for the short-term gains or the script kiddies, as they say.
Right. So it seems like when quantum is here and fully adopted, we will have some entirely new security concerns. That's going to be a whole new world. Correct? Incorrect?
100%.
Well, on that topic of looking ahead, I'd like to see, what do you see in the future in terms of developments around cryptography, large language models, security? I mean, what do you see in the next few years or so?
Certainly. So I think in terms of the near to short term future, I would expect a lot more conversations to take place around crypto agility, because I think everyone's reconciling to the fact that yes, post quantum cryptography is a key requirement, but that does not necessarily rip and replace classical. So, acknowledging the fact that the two will coexist and planning ahead of time for crypto agility is definitely a core requirement. And I'm not sure if organizations have already started full throttle on that line, because I still see many organizations trying to figure out their minimum viable capability requirement, because that, funnily enough, is also a prerequisite for crypto agility, inventorizing your app stack.
Wait, so what is crypto agility?
So crypto agility is when you would expect both classical and quantum computing to coexist,
Okay.
and where you would not necessarily, because PQC in itself is extremely cost intensive, effort intensive, and also compute intensive operation.
Right.
You wouldn't want to um, leverage PQC for the entire IT landscape because that would be excessive.
Hmm.
But picking and choosing where it makes most sense to make that kind of investment starts out with understanding how it's laid out in your environment today, what amounts to your critical infrastructure, critical business value driving data sets, and then aligning your PQC investments accordingly. The rest of it, maybe the 80% of your IT landscape could still sustain with classical cryptography, which is perfectly fine.
Hmm.
But allowing for the handshake to be seamless between quantum computing and classical is where crypto agility is key.
Aha. All right. So that's crypto agility. Anything
Mhm.
else in terms of what you see in the future?
I think, I've always believed this. AI is a double-edged sword, and I
Mm.
would definitely want more AI-based red teaming activities where AI-driven, simulated attacker-based, where you leverage existing TTPs to better fortify your perimeter. Because what happens is there's a lot of tribal knowledge that you can glean off of an attack. If that can be codified and leveraged for better red teaming exercises, I think there's significant value in doing just that.
Hmm. So it's a double-edged sword because it can be used for negative as well as positive.
That's right.
Yeah. Vidya, I think you said it. It's a lot of fascinating stuff. I learned a lot. Thank you so much for sharing your expertise, and please come back and talk with us again sometime.
Happy to. Thanks for having me, James.